All right, we're going to start by just talking about what an inverse is. We have two kinds of inverses. There's an additive inverse, like 3 plus negative 3 is 0. And then there's a multiplicative inverse in arithmetic, like 3 times 1/3 is 1. When we talk about matrices, we're always talking about multiplicative inverses. So with arithmetic, 1 is the multiplicative identity. And for matrices, they have to be square to have an identity. But it could be 1 0 0 1 or 1 0 0 0 1 0 0 0 1. You know, one's along the diagonal going to the right, and we call it capital I for the identity matrix. And the way that that works, if A is a square matrix, if you multiply A by the identity I, then you should get itself. Just like multiplying 3 times 1, you would get 3. And then you can do it in either order, which this is the only time that matrix multiplication is commutative. You can change the order, is with the identity matrix. Otherwise, A times B is not the same as B times A with matrices. Alright, so now it's like a notation. If x is 3, then like on your calculator you'll see an x to the negative 1. That's a multiplicative inverse. So that would be 1 over 3. Because, and they're inverses, because 3 times 1/3, they cancel each other out and get you the multiplicative identity 1. Now that's true with matrices. If A is a square matrix, then A inverse, not read A to the negative 1, but A inverse is the inverse, because matrix A times its inverse will give you the identity. Just like 3 times 1/3 gives you 1, then no matter what order you do, A times A inverse or A inverse times A, they should cancel each other out and give you that row, or they give you the diagonal of 1s, and every place else is 0s. So let's look at these two matrices and decide whether they're inverses of each other. So to do that, we'll have to multiply them, and we would have to get, since they're 2 by 2, we'll have to get 1 0 0 1. So we'll start with 3 2 7 5, I always read across, times 5 negative 2 negative 7 8. So for multiplication, hopefully you remember, you'll take and you'll do a row times a column, and then since that's row 1, column 1, this is going to be the element that goes in row 1, column 1. So it'll be 3 times 5 plus 2 times negative 7. And then row 1, column 2 will be 3 times negative 2 plus 2 times 8. And then I'm done with row 1, so moving on to row 2, I'm going to get 7 times 5 plus 5 times negative 7, and then row 2, column 2 will be 7 times negative 2 plus 5 times 8. So simplifying row 1, column 1, we have 15 plus negative 14, and I'm going to go ahead and just do that last matrix at the same time, simplifies to be 1. Now remember, the question is, are they inverses? So I do want a 1 right there, so far it looks good. So then I'm going to do row 1, column 2, which will give me negative 6 plus 16, which is 10. So we already know they're not inverses. But I'm going to go ahead and finish, just in case, if that were 0, then we would have to keep going. So looking at row 2, column 1, we get 35 plus negative 35. So had that 10 really been a 0, so far these would have looked like inverses. And then finally, row 2, column 2 would have been negative 14 and 40, which is 26. So that should have been a 1. So either way, these are definitely not inverses.